Welcome to Study Loop.
Okay folks, so in this video we're going to be talking about this problem. We have a proton, a deuteron, and an alpha particle all having the same kinetic energy enter a region of uniform magnetic field B, moving perpendicular to B. Okay, and what we're looking for is the ratio of the radius RD of the deuteron path to the radius RP of the proton path. So that's part A. And part B is the ratio R alpha of the alpha particle path to the proton particle path. Okay. So how are we going to do this? Well, first of all, you need to understand when you have a charged particle entering a region of uniform magnetic field, it's not going to have, a straight path. It's not going to, for example, if it was moving in a straight path before, then as soon as it enters this region, it's not going to keep having a straight path anymore because, it's going to experience a force that's perpendicular to its velocity. So it's going to whirl around. In this case, it's going to be traveling in a uniform, in a circle. Okay. So first of all, let's recall from Newton's second law that that F equals mass times acceleration, and for a particle in a circular path, that acceleration can be written by v squared over radius. Okay, and what is the force in this case? Well, it is the magnetic force, which is given by Q VB. I am ignoring the sine theta term in the cross product because it says in the problem that the velocity vector and the B field vector are perpendicular to each other. So that sine theta gives you a 1. So we can ignore it. Let's simplify this equation a little bit. So we have a V here on the right side and a V squared here on the left side. So we're going to cross it out. So we have radius equals mv over qb. Okay, so if you have two particles, the ratio of the path 1 and the over the radius of the second path is going to give you m1v1 q1b m2v2 q2b. Okay, and this is going to be simplified into m1v1 over m2v2 and then q2 over q1. Okay, so for two particles we can calculate the ratio of the radius of their path by this expression. Okay, and this expression is simpler than this expression because we don't know the radiuses of the three particles in this problem. But what we do know is the mass and the charge of the particles. Okay, but we have another quantity, which is the velocity. We don't know the velocity, but here's something that we do know. We know that the three particles all have the same kinetic energy, right? They all have the same kinetic energy. That means they all have the same 1/2 mv squared. So we can calculate a ratio of the velocities by okay, so let's just say that this is k, that stands for kinetic energy. So v is going to be equal to 2k over m square root, right? So if you have two particles, the ratio of their velocities is going to be given by v1 over v2 is going to be square root of 2k over m1 and then m2 over 2k. So this is going to be square root of m2 over m1. And this makes sense because if two particles have the same kinetic energy and one particle is heavier than the other, So let's say that the second particle is heavier than the first particle. So this ratio is going to be bigger than 1. That means this ratio is going to be smaller. I mean, also bigger than 1. That means this first particle is faster than the second particle because it's lighter. Okay, anyway. So that was just a little bit of a justification for this equation. And so we now have converted a ratio of velocities into a ratio of masses. And that's going to make our problem a lot easier to solve because we're going to plug this back in here. So R1 over R2 is going to be Q2 over Q1, M1 over M2, square root of M2 over M1. Okay, let's simplify this a little bit more. We have Q2 over Q1, M1 over M2. Sorry for my horrible handwriting. Let me double check if that's correct. Yeah, that's correct. Okay. So now we can start plugging in numbers, right? We have converted a ratio of radiuses into a ratio of charges and masses. Okay, so for part A, let's say that the first particle is the deuteron, and the second particle is proton. Okay, we're gonna calculate the ratio of the radiuses of the paths, not the radius of the particle itself, the radius of the path at which the particle is traveling. Okay, so R1 over R2 is going to be RD over RP, which is going to be given by the ratio of their charges. So Q2 is QP, Q1 is QD, multiplied by the square root of the first mass, which is mass of the deuteron, divided by mass of the proton. Okay, so what is the charge of a proton? It is, of course, positive E. What is the charge of the deuteron? It is going to be the same thing, positive E. And we know that a proton has approximately speaking, one atomic mass unit. It is actually slightly bigger than that, but we're going to ignore that teeny little bit of fraction there. So we're just going to say that the mass of a proton is 1 atomic mass unit, and the mass of a deuteron is going to be 2 atomic mass units. So we have a 1 times square root of 2 here, and that is going to be square root of 2, which is 1.4 something. Okay, 1.4. What about part B? So for part B, we're looking for alpha over proton, right? So we're going to say that the first particle is alpha, second particle is proton. So R1 over R2 is going to be R alpha over R proton, which is going to be Q2, which is Q proton, over Q alpha, square root of mass alpha, mass proton. Okay? What is the charge of a proton? It is positive E. What is the charge of an alpha particle? It is 2E. Okay? What about the square root here? Mass of an alpha particle is, it's heavy. It is 4 atomic mass units. It is 4. Mass of a proton is 1. Okay, so we have 1/2 times the square root of 4, which is 2. Did I do that right? No, this is not 2. This is 1. Okay, because square root of 4 is 2. 2 times 1/2 is 1. Okay, so this is the answer for part B. This is the answer for part A, and we are done. See you in the next video.